All right. Good afternoon, my fifth grade scientists. We are going to start with a video today. I've got my setup here, but bear with me if things get a little weird. I'm not a super professional at this yet. So today we're going to start with a little bit of a demonstration. I got some water here, some water here. I've got some 5 gram pieces there, exactly the same. My favorite game, sink or float. Sink. Float? If I've got water here and water here, why is one of the things sinking and one of the things floating? Ooh, that looks kind of dirty right there. Talk about that at your table real quick. Pause the video, see what you can come up with. All right. Hopefully you're back with me. You talked it over with your table. I am going to tell you the answer. Unfortunately, I can't hear your ideas, so we'll see how close you are. Now, one of the solutions is actually a salt solution. One is just plain water, and one actually has some salt in it. So the one that is just water does not have any particles in it. We would say that it's diluted because it actually doesn't even have any solute in it. Over here, we've got a solution of salt plus water. And if you drew the particles of salt in there, obviously you can't see the salt because it's dissolved, but it would look more like this. We've been using the terminology concentrated and diluted. This one over here is obviously concentrated because it has a lot more solvent compared to this one. This one has no solvent, so it's not even a solution. We can also throw in another word that we talked about a little bit in the fall. We haven't talked about it since then, though. Not only is it concentrated, this solution is actually more dense. We're bringing back that word density. We talked a little bit about density when we were talking about air in the atmosphere. Remember how if this is the atmosphere and this is the ground right here, most of the air molecules, the air particles in our atmosphere are hanging out down towards the ground. As you get up in the atmosphere, it starts to thin out, right? And it's a lot less concentrated. Let's make that a little bit more clear. Okay, it's a gradient right here. Down here, we would say that the air is concentrated. Okay, up here, it's more diluted. We can also say that the air is more dense down here and it's less dense up here. Now, we also know when it comes to density that things that are dense are going to sink. Things that are, let's see, less dense, not dense, less dense, they're going to float. That is why we know hot air, when the particles get excited and they get hot, they expand, right? They are less dense. They float towards the top. Same with the water. If we put that red hot water in the room temperature water, it goes up because it's less dense. Now, when we talk about more concentrated solutions or colder water, it's dense. It's sinking to the bottom. Same is happening right here. This solution right here does not have any salt in it. And so that gram piece is actually more dense than the water, so it sinks. Over here, we've got salt in there, and so it's more dense than the gram piece. Since that gram piece, 5 gram piece, is less dense than the salt solution, it floats on top. So last time when we were talking about the mystery solutions, we were talking about mass, how if it's more concentrated, it's going to have more mass because it's got more particles in it. Today, you've got 4 new mystery solutions, and you're going to see which one is the most concentrated by looking at its density. Okay? So more concentrated are going to sink, less concentrated solutions are going to float. All right, let's adjust this a little bit. You're going to be working at your tables. Everyone at your table is sharing one of these, but I do have quite a lot of materials so that you can either work with one person or some people at your table might even get their own. In order to do this, we're going to use a straw. We're going to use a straw holder, and we're going to use some pipettes. Okay, your pipettes are going to be in there like a paintbrush. You have to keep the pipette to its solution that it belongs to. Otherwise, you'll mess up the concentrations and you'll be super confused. So I'm going to show you with mystery solutions that don't match yours. I have a red mystery solution And this was supposed to be purple, but it looks kind of brown, but it'll do the same thing. We are going to take our pipette, and I hope this works. A bit more like this. My camera's going to fall down. There we go. Hopefully that works. If I put a solution in, just a little bit, right like this, it's obviously going to go towards the bottom because of gravity, right? There we go. If for some reason you have an air bubble that happens, you're just going to take your pipette and you're going to poke it so that there's no air bubbles. Then you're going to test another color. You're going to compare who has more concentration, who's more dense. Put this one right in here. Ooh, did you see that? I can no longer see where red is, and I no longer see where this one stops and ends. It's just all that icky brown color. So that means that this one was more concentrated. It sank to the bottom. Once you have one piece figured out, you're going to take the straw, pinch it, let it out like this, and you're going to try something else to prove it. What if we put this brown color on the bottom? A little bit, you don't need a lot. And then we put red on top. Do you see how we can still see the brown down here and the red up here? The red is sitting on top of the brown. That means the red does not want to sink. It is less dense, which also means that it's less concentrated. So of these two solutions, this one is more concentrated. It has more salt in it. This one does not have as much salt as this one because this one floats, this one sinks. Make sense? All right. You are going to be testing your solutions. I want to know which one is the most concentrated, which one is the least concentrated, which one is the second most concentrated, and which one is the second least concentrated. So I need to know in order for all of them. You'll find that on your notebook sheets. When you have the answer, you should be able to prove it finally by putting all four of these colors into a straw, and it should stack up so that you can see all the colors without mixing at all. That would be the right answer. Okay. Once you have that, you're going to give me some sentences with some proof and some evidence. One final thing I want to tell you. I'll go get a bowl real quick. Okay, you should have a discard bowl as well at your table. If for some reason, well, when your straw, take it off like that, straw holder gets too icky and full of color, you're just going to take the straw holder and you're going to dump it in the discard bowl. That way it doesn't overflow. All right? Be responsible, be respectful, make sure you're not making a mess, and if you do make a mess, use towels to clean it up. All right, this one's weird. Bye!